All right, let's talk about something that is, well, legendary. I'm talking about Japan's railway network. For decades, it's been the absolute gold standard for precision, reliability, and just mind-blowing punctuality. But what happens when that perfect system starts to fail?
You know, when you think of JR East, the company that runs the trains in and around Tokyo, you just think of perfection. This is a network that handles an insane number of people with an on-time performance that the rest of the world can only dream of. It's supposed to just work, flawlessly. But then, something happens that should be impossible. I mean, it's straight out of an action movie. As Shinkansen, a bullet train, literally uncouples, it comes apart, while flying down the track at over 300 kilometers an hour. This wasn't just some accident. This was a complete breakdown of how the system is supposed to function.
And that wasn't just a one-off thing. Picture this. Tokyo, the biggest metropolis on the planet, is brought to a dead stop. Not for a few minutes, for 8 solid hours. We're talking more than 500,000 people stranded, all because of one simple mistake after some routine work.
And then there was the cascade failure. A single, tiny metal bracket breaks. That one little break triggers a destructive chain reaction that just shreds equipment on train after train. The entire Yamanote loop line, which is basically the heartbeat of Tokyo, completely shut down. So what on earth is going on here?
Yeah, these aren't just isolated incidents or some crazy string of bad luck. They're symptoms. And to figure out why this supposedly perfect system is starting to crack, we've got to look a lot deeper. So, let's play detective. Let's really dissect these failures, because each one gives us a different clue. And all those clues point toward a much bigger and way more complicated problem.
In fact, you can sort of lump all these recent troubles into 3 really distinct buckets. You've got physical things failing, like the overhead power lines. You've got the high-tech control systems on the trains themselves glitching out. And you've got basic human error causing these massive shutdowns. So this isn't just one problem repeating itself. It's like they're fighting a war on 3 different fronts.
And just look at the variety here. It's kind of wild. A pole is leaning over and causes a collision. A tiny electrical short makes a bullet train split in 2. A single worn-out bracket creates a domino effect of destruction. And one forgotten step after a construction job paralyzes one of the busiest train lines in the world. The scale and the sheer diversity of these problems, it's just staggering.
So your first thought might be, okay, easy, the system is just getting old. And look, that's part of the story for sure, but it is not the main headline here. The real culprit is something much more modern and a whole lot trickier to solve.
This right here gets to the absolute core of it. The old problem was simple, right? Metal gets old, things wear out, you can see it, you can inspect it. But the new problem is complexity. The whole system has become so interconnected, so intertwined, that a tiny invisible glitch in one corner can trigger a catastrophic collapse everywhere else. It creates failures in ways that were never even possible before.
And this helps explain those big physical failures. It's a concept called a serial safety structure. Just think of those old-school Christmas lights, where if one single bulb burns out, the entire string goes dark. That's how parts of this system are built. One small component fails and it's not contained, it just takes down the next part, and the next, and the next.
So let's go back to that Yamanote line disaster. It started with one single small bracket that just wore out and broke. Because it broke, the power line it was holding sagged a little bit. The next train comes along, its pantograph, that arm on top that gets power, snags that sagging wire, breaks, and then that broken part basically turns into a wrecking ball, destroying everything in its path for miles. One tiny failure led to total system paralysis.
Now, for the high-tech failures, there's a different idea at play: logical fragility. This is the scary new reality of our digital world. It means your hardware, the physical stuff, can be perfectly strong, absolutely robust, but it can be completely defeated by a software bug or a tiny electrical error. That Shinkansen coupling didn't physically break. It was told to separate by a faulty electrical signal at 315 kilometers per hour. The logic failed, not the steel.
So, if your new enemy is this deep, hidden, almost invisible complexity, how do you even begin to fight that? You can't just tell people to inspect things more often. JR East and its partners are turning to a whole new strategy, a new arsenal of technology called smart maintenance.
This whole strategy starts with a really fundamental shift in thinking. They're moving away from the old model, time-based maintenance, where you replace a part every 5 years just because the calendar says so.
The new model is condition-based maintenance, where they use real-time data to fix the exact part that needs it right before it's actually about to fail.
So a huge part of this new tech toolkit is basically predictive power. They're using AI that can literally listen to the vibrations of a train motor, learn what sounds normal, and then detect these microscopic changes that signal a failure is weeks or even months away. It's all about spotting these tiny anomalies in the data before they ever become a real, physical problem.
Another part of the toolkit is about seeing what the human eye just can't. They're using drones with AI that can analyze thousands of images to spot hairline cracks on those little brackets. They have these high-speed vehicles that create a perfect 3D digital map of the entire railway so they can spot if a pole is leaning by just a few millimeters. They can literally see the invisible threats.
And finally, they're using technology to build a kind of digital safety net for human error. They're creating system interlocks that make it physically impossible to, say, turn the power back on if a safety device is still in place. They have digital checklists on tablets that must be completed before the system even allows the next step. It's about taking that huge burden off of human memory and building the safety right into the system itself.
So what's the big picture here? What does all of this really tell us? Well, it points to a massive shift in how we have to think about safety, not just on railways, but really in any complex system that we all rely on every day.
Just let this number sink in for a second. Almost 700,000 people. That's the impact of one person forgetting one single step in a deeply complex, interconnected system that an entire city needs to function. The margin for error has become basically zero. This is the new reality. The biggest challenge isn't just about replacing old parts anymore. It's about learning how to safely manage the incredible and sometimes scary complexity that we ourselves have created.
And this brings us to the ultimate change in thinking. The goal isn't perfection anymore, because in a system this complex, a truly failure-proof system is impossible. The new goal is resilience. It's about building a system that's smart enough to anticipate failure and can predict it, contain it, and manage it gracefully when it inevitably happens, so that one tiny broken part never, ever brings an entire city to its knees again.
And you know, this really isn't just a story about trains in Japan. It's a story about our power grids, our financial networks, the internet itself. So I'll leave you with this question to chew on. As our own world gets more and more complex, what can we all learn from the troubled trains of Tokyo? Thanks for joining me.